Curious. Richard Feynman once described Euler's identity, e to the I pi plus 1 equals 0, as the most remarkable formula in mathematics. To the average person, it looks like an incomprehensible soup of letters and numbers. The confusion usually starts with the letter e. We learn early on that e represents exponential growth. In its simplest form, it describes a quantity getting larger at a faster and faster compounding rate over time. Take a look at this standard horizontal number line. When we map normal exponential growth here, our perspective is entirely trapped in one dimension. The value is restricted. It can only move left or right. Then we introduce I, the imaginary unit. In a typical classroom, I is taught as a placeholder for the square root of -1. We are rarely taught to see it as a physical direction. Euler's formula provides a literal set of mechanical instructions for physical motion. By shifting our perspective away from rigid algebra and toward physical geometry, we can turn this static equation into a dynamic engine that breaks free of the one-dimensional line. Here is that new geometric setting. This is the complex plane, featuring our standard horizontal real axis, crossed by a vertical imaginary axis. We start with a vector resting at the number 1. Normal growth pushes a value forward. Multiplying by an imaginary rate pushes the value perfectly perpendicular to its current path, forcing a 90-degree turn. If we apply this perpendicular force continuously, the physics get counterintuitive. Because the force pushing the vector is always at a right angle to the direction it is moving, the vector's length remains identical. It only changes direction. Applying that unrelenting orthogonal force naturally generates a perfect, unending orbit around the origin. It behaves exactly like a clock hand sweeping around a dial. Doubling the imaginary growth rate doesn't break the circle or push the point outward. It simply makes the clock hand spin twice as fast. Imaginary exponents act as a mathematical steering wheel. The letter I represents a rotational force. Now that we have this continuous circular motion, we must pinpoint the exact location of this sweeping clock hand at any given microsecond. We can track it by breaking the circular path down into 2 simultaneous, measurable shadows, one horizontal and one vertical. The cosine part of Euler's formula tracks the horizontal distance. It records the point sliding back and forth along the real axis. Meanwhile, the imaginary sine part of the formula tracks the vertical distance as it slides up and down the imaginary axis. This is the mechanical meaning of Euler's formula. It is a translation device, converting continuous circular motion into exact, predictable grid coordinates. What happens when we combine the continuous rotational force of imaginary numbers with the outward compounding thrust of real exponential growth? We get a mixed growth equation. By raising e to the power of a real plus an imaginary number, we tune 2 separate engines simultaneously. If the real growth rate is positive, the point sweeps around the circle while zooming outward, creating an exponentially expanding spiral. Conversely, if negative, the amplitude decays. The radius shrinks, tightening the spiral inward until it collapses. Mixed complex growth provides a unified framework, allowing us to plot any trajectory in 2-dimensional space by adjusting the independent dials of rotation and scale. The shape generated by this mixed growth is the logarithmic spiral, historically known as the spira mirabilis, or the miraculous spiral. Because it is built on exponential growth, the spiral is self-similar. It can scale infinitely, larger or smaller, without altering its fundamental shape. Biology leverages this specific exponential spiral to maintain integrity as an organism grows, as seen in the chambers of a nautilus shell. We find the same logarithmic spiral organizing complex natural systems at a botanical level in the face of a sunflower. At the cosmic scale, the exact same rotational and expansive growth formula dictates the sweeping physical structure of spiral galaxies. Euler's formula provides the geometric framework for periodic motion, waves, and the infinite scaling found throughout the natural world.